The Olentangy River holds great significance for the central Ohio area. Starting in Crawford County and merging with the Scioto River in downtown Columbus, this 88-mile-long waterway provides many ecosystem services to the surrounding region and watershed. For one, the river yields most of Delaware County's drinking water. It also provides habitat for several species of birds, mammals, fish, macroinvertebrates, and plants. Additionally, the river trail is frequented as a path for runners, bikers, and visitors alike. As such, restoration will benefit more than just the ecosystem. In the 20th century, a total of 12 dams were constructed along the Olentangy River, serving a multitude of purposes, from supplying water and irrigation, generating hydropower, flood control, and more. However, near the start of the century, dam implementation began to be seen as an ecological issue throughout the country, and dam removal projects started to become more common. Dams are not only detrimental for wildlife diversity and the function of riverine ecosystems, but humans as well. Commonly known as a drowning machine, low-head dams may put those that recreate the waters in danger, and rescue is difficult. Removing dams would benefit not only the biological community, but enhance safety for recreation goers. The restoration challenge we decided to focus on was the Fifth Avenue Dam Removal Project. The dam's scale of influence spans from just north of the Lane Avenue Bridge down to the Fifth Avenue Bridge. Constructed in 1935, this low-head dam is structured at 8 feet tall and 470 feet wide. The dam once served as a source that supplied cooling water for Ohio State University's power plant, which is no longer in use. Prior to dam removal, the Olentangy River resembled a lake environment with ripples that restricted water flow, negatively impacting wildlife and impeding migration of freshwater aquatic species. Dams break up rivers and transform what was previously a free-flowing aquatic ecosystem into a stagnant water body, disrupting natural movement of water and sediments, which lead to depleted oxygen levels that are unsuitable for organism survival. As water quality diminishes from pollution and sewer runoff, and organic matter accumulates, a reduction in the abundance and diversity of native species is observed. Between 2002 and 2004, the Ohio EPA issued a consent decree to remove the dam. Upon evaluation, the site, and more specifically the area around Ohio State's campus, did not meet the water quality standards set by the EPA. By 2006, an agreement to remove the dam was established. The restoration process began in the fall of 2012 and took approximately 2 years to complete, and was led by FLOW, Friends of the Lower Olentangy Watershed, a nonprofit made to keep the Olentangy River and its tributaries clean and safe. One major challenge for the project was its cost. Totaling at roughly $6.9 million, this proposal required major financial contributions from the Ohio EPA, City of Columbus, OSU, and public utilities.
The goals of the project followed the SMART process. They are specific, measurable, actionable, realistic, and timely. The objective was to improve the water quality and overall river and ecosystem health, generating new riparian habitats in the corridor, and creating enhanced safety and additional opportunities for recreation. Removing the dam released the trapped water within the affected area. This allowed for the migration of fish and other aquatic species, as well as the reduction of trapped pollutants within the water. The introduction of wetlands provided a buffer for sediments and pollutants from entering the river, and it also improved the natural aesthetic of the river. The dam removal aspect is just the first step, as the scope is a part of a broader vision for improving the Olentangy River. Once this was completed, various other restoration projects were in place, including river feature reconstruction and riverside planting. To start, the top 3 feet of the 8-foot dam was removed using bulldozers and other heavy equipment. Only a portion of the dam was removed in order to save money. The sediment removed above the dam was used for the construction of new river banks, providing soil for native vegetation and the formation of a new riparian ecosystems, achieved by re-engineering of the ecosystem itself through collaboration with the U.S. Army Corps of Engineers. Muddy banks that were once submerged are now above water. The area underwent construction of numerous wetlands, riffles, as well as pools that reconnect storm drains to newly reduce the water level. The site was also planted with grasses, sedges, and forbs that can tolerate high water environments and provide food and habitat for fish and bird species. Further up on the bank, native trees and shrubs were planted to help provide shade and regulate water temperature. Though there are potential downsides to recognize. Immediately after removal, Sediment that build up behind the dam over time may contain toxic chemicals, and upon release, there are likely to be increased water turbidity, leading to temporary declines in water quality downstream. However, it has been found that these short-term impacts are largely outweighed by the long-term benefits of the system as a whole. Reference sites are important to keep in consideration to account for other sites matching both spatially and temporally. One such occurred at a similar ecosystem within the vicinity at a different place and at a different time. River Street Dam, a similar project, was removed in the city of Delaware in 2006, and biological monitoring completed by the EPA several years later noted remarkable recovery post-removal, providing valuable feedback to inform the removal and river restoration of the Fifth Avenue Dam. With any restoration project, it is important to take an adaptive management approach. This includes embracing uncertainty, learning by doing, analysis of existing knowledge, improving management, and involving stakeholders. Flow has taken an adaptive management approach to this project by monitoring its progress and learning along the way. They have involved multiple stakeholders, agents, and partners, including the Ohio EPA, the City of Columbus, former Columbus Mayor Michael B. Coleman, and Stantec Consulting Services. For future outlook, it's pertinent to acknowledge that restoration takes time. Sites involved in this project will continue to be monitored for many years, as planted vegetation requires several years to fully mature. On a hopeful note, the Fifth Avenue Dam removal has inspired more dam removal projects throughout the city of Columbus, along with more river cleanups and volunteer invasive species removal projects planned for years to come.